Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an isometric 3D projection corresponding to an engineering object into which the front view face, the right hand side view face and the top view face of this particular solid, they have been combined into an isometric 3D projection over here. Using the information available with us into the 3D construction corresponding to this solid, we are required to obtain the front view orthographic projections, the right hand side view orthographic projections and the top view orthographic projections corresponding to this engineering object. So in order to obtain orthographic projections of this engineering object, we must obtain the dimensions of the front view face, the top view face and the right hand side view face corresponding to this solid over here. Now as the observer is going to look at the solid from the front side, so now we can check that we have not been provided with the total width of the solid over here. So we have been provided with this information that the distance between this center point and this center point, it happens to be 38 millimeter on the right hand side and 38 millimeter onto the left hand side. So the distance between these two center points, it will become 76 millimeter. And then we have been provided with this information that the radius of the circular arc on this side is also 15 millimeter and the radius of the circular arc on this side, it will also be equal to 15 millimeter. So 15 plus 15 plus 38 plus 38. So this way the width of the solid happens to be 106 millimeter over here. Similarly, when we are going to look at the solid from the front side, once again, total height of the solid has not been provided to us. So we need to obtain the height of the solid by looking at the constructional details of the solid over here. So we know that the distance of the center point from the base of the solid, it happens to be equal to 35 millimeter, while this radius of the semicircular top portion of the vertical wave, it happens to be equal to 15 millimeter. So 15 plus 35. So the height of the solid will be equal to 50 millimeter. So the front view face corresponding to the solid will be measuring 106 millimeter by 50 millimeter. Similarly, when we are going to look at the solid from the top, so we will be observing that the width of the solid will remain the same as 106 millimeter, while the depth of the solid has been provided to us as 64 millimeter. So the top view face corresponding to the solid, it will be measuring width 106 millimeter and depth of the solid is equal to 64 millimeter. Similarly, when we are going to view the solid from the right hand side, so we observe that depth of the solid happens to be 64 millimeter and the height of the solid happens to be 50 millimeter. So the side view face corresponding to the solid, it is going to have dimensions 64 millimeter by 50 millimeter. So with this information, we are required to obtain the orthographic projections of the solid. And we know that into the first angle projections, the front view orthographic projections will be obtained above the XY reference line. The top view orthographic projections will be obtained below the XY reference line. And the right hand side view projections corresponding to the solid will be obtained on the left hand side of the front view projections over here. So now we know that the front view face corresponding to the solid is going to have the dimensions equal to 106 millimeter width and 50 millimeter height. So now we have drawn two vertical projector lines into the front view projection view and we have extended them into the top view projection view over here. And the distance between these two vertical projectors we have marked equal to the width of the solid, which happens to be 106 millimeter. Now we also know that the height of the front face happens to be 50 millimeter. So now we are going to draw a horizontal projector line into the front view projections, and we have extended this horizontal projector line into the right hand side view projection view over here. And this height of this horizontal projector line above the XY reference line we have marked as 50 millimeter. So now the dimensions corresponding to the front face 106 millimeter width and 50 millimeter height, they have been obtained into the front view projections over here. So now we know that the top view face dimensions corresponding to the solid will be 106 millimeter width of the solid, which we have already obtained, and we know that the depth of the solid, it happens to be 64 millimeter. So two horizontal projector lines, they have been drawn into the top view projection area, which are separated by the distance 64 millimeter, so that these two projector lines, they are going to represent the depth of the solid is equal to 64 millimeter, and the two horizontal projector lines, they have been appropriately transferred into the right hand side view projection area using this transfer line, which has been drawn at an angle of 45 degree over here. So now into the right hand side view projection, now we can check, we have obtained the right hand side view face of the solid measuring depth of the solid is equal to 64 millimeter, height of the solid is equal to 50 millimeter. So the front view face, the top view face and the right hand side view face corresponding to the solid, it has been obtained into the orthographic projection views over here. So now we are going to divide the solid into multiple elements, and then we are going to project the constructional details of all of these three elements into the orthographic projections over here. So the element number 1, it happens to be a horizontal wave which is having height is equal to 12.5 millimeter and width is equal to 106 millimeter. Whereas element number 2, it is a vertical wave which is existing towards the front face of the solid, and this vertical wave, it is carrying a central hole over here, and this vertical wave is having the dimensions height is equal to 50 millimeter, the depth, it has been provided to us as 12 millimeter, and the width has been provided to us as 30 millimeter. We can check this radius happens to be 15 millimeter. So this width of this vertical web happens to be 30 millimeter. So the element number 3, it is again a vertical wave which is lying towards the rear side of the solid over here. So now to begin with, we are going to start with construction of front view projections corresponding to this horizontal wave which is having height is equal to 12.5 millimeter from the base of the solid. So we can check from the horizontal plane, we have marked the height of this horizontal wave as 12.5 millimeters, and we have drawn a horizontal projector line into the front view projections, and we have extended this projector line into the right hand side view projection area over here. So now we know that there is a circular portion which is existing on the left hand side face of this horizontal wave, and circular portion is also existing on the right hand side face of the solid over here, and the diameter of the circular portion, it happens to be 30 millimeter, or we can say the radius of the circular portion happens to be 15 millimeter. So now from the left hand side face of the solid, we are going to mark a distance of 15 millimeter towards right hand side, so that the center point corresponding to the circular portion of the top face of the horizontal web can be obtained onto the left hand side portion of this solid over here. So now we have marked a distance of 15 millimeter from the left hand side face of the solid, and the center line corresponding to the circular portion has been obtained into the front view projections, and this center line has been extended into the top view projections as well. Similarly, onto the right hand side, once again we can observe this radius of the circular portion happens to be equal to 15 millimeter. So at a distance of 15 millimeter from the right hand side face, we have marked this center line corresponding to this circular arc which we need to obtain into this right hand side portion of the horizontal web over here. So now we have marked the center line at a distance of 15 millimeter from the right hand side face into the front view projections, and we have extended this projection of the center line into the top view projections over here as well. Now we know that at the center, because the total width of the solid happened to be 106 millimeter, so at a distance of 38 millimeter from this center line, or at a distance of 53 millimeter from the right hand side face, so either of the distance we can mark. So we have marked this distance of 53 millimeter from the right hand side face over here, so that this center distance is 15 millimeter. So center to center distance will be equal to 38 millimeter over here. So another center line we have marked into the front view projections, which is going to depict the location of the circular holes which are lying into the vertical web, and this center line is also going to depict the circular semicircular portion corresponding to the front side vertical web, which is element number 2. Similarly, the center point, this center axis line, it is also going to depict the center of the circular portion of the vertical web, which is element number 3, which is lying onto the rear side of the solid over here. So this way, this center line we have obtained into the front view projections, and the center line has been extended appropriately into the top view projections over here. Now we know that the width of this vertical web, it happens to be equal to 30 millimeter, where from we have obtained this distance of width of the web equal to 30 millimeter, because we have been provided with the information the radius of the semicircular web, it happens to be equal to 15 millimeter. So this diameter becomes 30 millimeter. So the two vertical edges of the vertical web, so they will be separated by a distance of 30 millimeter from each other, and this is symmetrically located at the center. So from a distance of 53 millimeter from the right hand side face, now we have obtained the center point. So through this center point, 15 millimeter on the either side, we have marked 2 points over here, so that the width of this web equal to 30 millimeter we have been able to obtain into the front view projections over here. So we have marked 2 vertical projector lines separated by a distance of 30 millimeter, which are symmetrically arranged around the center point of the width of the solid over here, and these 2 projector lines we have extended appropriately into the top view projections over here. Now we have evaluated that the distance of the center point from the top face will be equal to 15 millimeter. So this will provide us with the center point corresponding to the circular arc of the vertical web. It will provide us with the center point corresponding to the circular hole, which is having the diameter of 12 millimeter, which is existing into the 2 vertical webs over here. So now at a distance of 15 millimeter from the top surface, again a center line has been drawn into the front view projections, and this center line has been extended into the right hand side view projections of the solid over here. Now we have obtained the center point corresponding to the circular arc over here. So we know that this radius happens to be 15 millimeter over here. This height is 15, this distance is also 15, and this distance is also 15. So with this as our center point, Now we have marked the radius of the circular portion corresponding to the vertical web equal to 15 millimeter over here. So once we obtain this radius of the arc is equal to 15 millimeter, now we can check the vertical web. It is extended up to the base of the solid over here into the front view projection. So once we mark this arc over here, now two vertical projector lines we have marked into the front view projections over here. Now we can mark the circular portion of this hole over here, which can be drawn corresponding to the center point which we have already located. So through this center point, using a radius of 6 millimeter or a diameter of 12 millimeter, we have marked the circular hole which is existing into element number 2 vertical wave, which happens to lie onto the front side of the solid, and a circular hole which is existing into the element number 3, that is the vertical wave, which is going to lie onto the rear side of the solid. And we must remember that because of the symmetry, these two holes, they are going to overlap with each other into the front view projections over here. And now we can check the portion of the horizontal web which is lying onto the left hand side of this particular vertical web, and this portion of the horizontal web which is going to lie onto the right hand side of this vertical web. So both of these portions, they will be visible to the observer as apparent shape projections into the front view projections as rectangular projections over here. So we can check this is a big surface over here. This is also a big surface over here. But because of the inclination of this surface and this surface with respect to the vertical plane, we are able to obtain the shorter projections or the apparent shape projections into the front view projection over here. So this way, the front view projections of the horizontal wave on the left hand side, front view projections of this horizontal wave onto the right hand side, they have been obtained into the elevation projection view. And we also know that from this center point, we can check this is the center point, this is the center point. So from this center point and from this center point, we have got two holes available into the horizontal web on either side of this vertical web over here. And this diameter of the holes which are available into this horizontal web, it happens to be equal to 15 millimeter. So from the center point, we have marked an offset of 7.5 millimeter on the left side and the right side. So the location of the hole into the left hand side portion of the horizontal web, it has been located. Similarly, through the center point, once again, we have obtained the offset of 7.5 millimeter on either side, so that this location of the hole into the horizontal web, we are able to locate into the front view projections over here. Now these two holes, they are not visible to the observer from the front side orientation because they have been covered by this solid portion of the solid. So they will be available as hidden line projections into the front view projections over here. Similarly, one more thing we need to observe. This is the portion of the horizontal web which is lying over here between these two elements, element number 2 and element number 3. But this horizontal portion of the web which is lying behind this element number 2, this will not be visible to the observer from the front. So corresponding to this horizontal surface, dotted line or hidden line projections will be available between these 2 points over here into the front view projections over here. So now let us proceed to evaluate the top view orthographic projections corresponding to this solid. So we know that there are two vertical webs which are existing, one on the front side, one onto the rear side, and the depth corresponding to each one of these vertical webs, it happens to be 12 millimeter. So now we can check. We have marked a distance of 12 millimeter corresponding to the depth of the web onto the rear side. We have marked a distance of 12 millimeter corresponding to the depth of this vertical web onto the front face of the solid over here. Now we have marked two horizontal projector lines over here, one on the rear side, one onto the front side, corresponding to this depth of the web corresponding to element number 3 and element number 2 over here. And these two horizontal projector lines, they have been appropriately transferred into the right hand side view projections using this transfer line over here. So now we know that the center point corresponding to these two holes which are available onto the horizontal web, they are located at a distance of 32 millimeter either from the front side or from the rear side face of the solid. So now we have marked a distance of 32 millimeter from the rear face of the solid, so that the center line corresponding to this hole and this hole, one hole will be available on the left hand side, one hole will be available onto the right hand side of the horizontal web over here. So once we locate this center point corresponding to the two holes which are available onto the horizontal web into the top view projections, now this position of the center line has been appropriately transferred once again into the right hand side view projections using this transfer line over here. So now we can check center point corresponding to this hole on the left hand side has been located over here. The center point corresponding to this hole onto the right hand side has been appropriately located over here. So now once the observer is going to look at the solid from the top, we are going to observe the rectangular projections corresponding to the element number 3, that is this vertical web which is going to lie onto the rear side of the solid. Similarly, rectangular projections from the top, they will be visible to the observer from the top corresponding to this vertical web or the element number 2 which is available towards the front face of the solid over here. And the dimensions of this rectangular projection will be the width is equal to 30 millimeter and the depth is equal to 12 millimeter. Now another thing we know over here, that if we have to draw this circular arc over here, so this distance between this point and this point, it will be equal to 30 millimeter. Why? Because we know that from the center point, once we draw the semicircular arc over here, so this distance will be 15 and this distance will also be 15. So now from the center point we can check, this is our center line over here. We have marked two horizontal projector lines which are at a distance of 15 millimeter towards the front side and 15 millimeter towards the rear side, so that these 2 points on the left side they are obtained, so that we can mark this curve having radius is equal to 15 millimeter towards the left hand side portion of the solid. Similarly, we will be able to mark these 2 points corresponding to the circular portion over here. So 15 millimeter will be the radius towards this side and 15 millimeter will be the radius towards the front side over here. So this way we have been able to obtain the end points of the circular portion of the arc which will be obtained on the left hand side and end points corresponding to the circular portion of the arc which will be located onto the right hand side over here. And these two horizontal projector lines, again they have been appropriately transferred into the right hand side view projections using this transfer line which had been drawn at an inclination of 45 degree. So now we have obtained the center points. We can check center point on the left hand side, center point onto the right hand side. Now the 3 points corresponding to the arc having radius 15 millimeter, they have been obtained. Point number 1 at a distance of 15 millimeter from the center point. Point number 2 at a distance of 15 millimeter from the center point, and this distance is also 15 millimeter. So this we have marked it out over here. So now we can mark through this center point an arc having radius is equal to 15 millimeters such that it should be passing through point 1, point 2 and point 3. Similarly, another arc onto the right hand side we have also drawn having radius is equal to 15 millimeter. So both of these circular portions, they have been appropriately marked into the top view projections having radius is equal to 15 millimeter. So now the circular portion has been obtained. The endpoints corresponding to the vertical portion of the web, they have also been obtained. So now we can join, we can check these inclined portion from this point to this extreme point, from this point to this extreme point, another inclined portion we can obtain. From this point to this point, another inclined portion we can obtain. From this point to this point. So fourth inclined surface we can obtain. So all the four inclined surfaces we have been able to obtain into the top view projections over here. So now we also know that there are two circular holes which are available onto the horizontal web. One circular hole exists onto the left hand side. Second circular hole exists onto the right hand side portion over here. So the center points we have already located. So we know that the radius of this circular hole happens to be 7.5 millimeter or the diameter is 15 millimeter. So using diameter of 15 millimeter through these two center points, one on the left side, one on the right hand side. So we have been able to obtain the top view projections corresponding to these two circular holes. And one more thing we need to note down. This is a circular hole which is available in the vertical web corresponding to element number 2, which is not visible to the observer from the top. This is a circular hole having diameter is equal to 12 millimeter existing into the vertical web element number 3, which is again not visible to the observer from the top. So the hidden line projections corresponding to hole number 3 and hidden line projections corresponding to hole number 4 we are going to obtain over here. So the projector lines corresponding to this hole we have already obtained into the top view projection. So now hidden line projections corresponding to the hole number 3, they have been obtained corresponding to element number 2. Hidden line projections corresponding to hole number 4 which is available in element number 3. They have been appropriately obtained into the top view projections over here. So this way we have been able to obtain the top view projections corresponding to this engineering object. Let us now obtain the right hand side view orthographic projections corresponding to this solid. So as the observer is going to look at the solid from the right hand side, so one rectangular projections we will be able to obtain corresponding to this portion of the horizontal web over here. So this is a curved portion, but it will be available as a rectangular web which is available at the base of the solid into the right hand side view projections over here. So this portion will be projected as apparent shape projections corresponding to this circular and inclined portion of the horizontal portion of the web over here. Similarly, we have got two elements over here which are the vertical webs, element number 2 and element number 3. So element number 2 will also be projected as a rectangular projection into these right hand side view projections over here, and the dimensions will be depth is equal to 12 millimeter and the height will be equal to 37.5 millimeter because the total height is 50. So the height of the base web, it happens to be 12.5. So the remaining height of the vertical web from the right hand side view, it will be 37.5 millimeter over here. Similarly, corresponding to the rear side vertical web, again a rectangular projection has been obtained appropriately over here. Now we know that there are two holes which are available with us into these two vertical elements, but none of these two holes they are visible to the observer from the right hand side projections over here. So corresponding to hole number 3 and hole number 4, now we have obtained the horizontal projector lines from the front view projections extended into the right hand side view projections over here. Now we can mark the location of these two holes which are available in the vertical elements, element number 2 and element number 3 over here. So into the vertical webs, these two holes, they have been shown using the hidden line projections over here. Similarly, we know that there are two more holes available, hole number 1 and hole number 2, having diameter is equal to 15 millimeter, which are again located centrally from the right hand side view orientation over here. So from the center, we'll have the offset of 7.5 millimeter on either side, and these two holes, they will be overlapping with each other into the right hand side view projections. And since these holes have been covered by this surface area and this surface area, so they will be visible to the observer as hidden line over here. So from the center, again we can check, corresponding to these two holes, we have drawn these two horizontal projector lines from the top view projections and transferred these projector lines into the right hand side view projections over here. So we have been able to obtain hidden line projections corresponding to two circular holes having diameter is equal to 15 millimeter, obtained as hidden line projections into the right hand side view projections over here. Another thing we can observe, this portion of the horizontal surface which is lying behind this particular vertical wall of the web over here, it should have been drawn as a dotted line. Similarly, this portion of the vertical web which is going to cover this horizontal surface should have been drawn as a dotted line over here. But this portion which is corresponding to the horizontal surface covered by this vertical web on the other side, and this portion of the horizontal surface covered by this vertical web, they cannot be obtained as dotted lines over here because this has been obtained as an object line into these side view projections, and these object line side view projections corresponding to these front walls, they are going to supersede the dotted line projections corresponding to the dotted line projections which are available with us corresponding to the rear side walls of the vertical web over here. So that is why a continuous object line projection will be visible over here into the right hand side view projections, which will be visible to the observer. So this way we have been able to obtain the front view orthographic projections, the top view orthographic projections, and the right hand side view orthographic projections corresponding to an engineering object whose 3D isometric projection view it was provided to us. So this is all for today. I hope that through this discussion you would have developed an understanding how do we proceed to evaluate the orthographic projections of an object when the 3D isometric projections of the object they are available with us. So we are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.